Okay, so this next problem is next handout is pretty simple. We're just making sure that we know how to plot an e to the x and an ln x type of graph, right? So for e to the x, it's pretty simple. I think we briefly talked about it maybe in class, but if we didn't, we just need 3 points, 0, comma 1, the e to the 0 is 1, 1 comma e, and negative 1, 1 over e, and we're just going to use those 3 points, 0, 1, let me do this in red, let's go 0, 1, 1 e. Now e is 2.7, so put it in the right spot. If I'm using 1 unit for 1 tick, then that's going to be right around here. And then 1 over e, if you do it in your calculator, you'll see it's 0.37, so that dot should be somewhere there. We know we're going to have a horizontal asymptote along the x-axis, and we can just connect this graph like this, right? So that's very basic, but you do want to know how to do that. Okay, so, and then these things we know how to do, just like any exponential. The domain is negative infinity to infinity. The range for this basic y is equal to e to the x, well, the y values start at 0, not including 0, and they go to infinity. And behavior, as x goes to infinity, y goes to infinity. As x goes to negative infinity, y goes to the horizontal asymptote, right? The horizontal asymptote here is at 0, and in this particular graph, we go to that as x goes to negative infinity. The x-intercept here we have none, and the asymptote again, this is just y is equal to 0. Make sure you say y is equal to 0 and not just 0, right? Because this is the equation of a line. Okay, and then all you need to know in terms of transformations of this parent function, we're not going to do the full-blown, a times b to the x minus h plus k. We're just going to do simple ones like you should know how to do y is equal to e to the x minus 2, for example, right? So now this right here will be my horizontal asymptote at y is equal to negative 2. So I like you guys to come in and draw that first, right? So there it is, y is equal to negative 2. That has to be a dashed line, so make sure that you do that. And then figure out your new origin. I'm not going to give you any horizontal shifts on the e to the x graphs, right? Because it just gets more complicated. You'll do that in pre-calc. But you're going to have, this kind of situation, hk is 0, negative 2, right? So your new origin is right here, and you're just going to plot the graph from there. You're going to plot the same numbers that we used in the first example, right? But just counting from our new origin, right? So this is like our over and our up from the new origin. I'll do this one in blue. So this will be 0, 1, and then 1 over from that new origin. I'll put that as an x. 1 over from there is 2.7, and 1 to the left of that is 0.4, and then we just connect our exponential graph like that, okay? That's a basic, very simple up-down transformation of a e to the x graph. And then you have the same, domain is that, and then range is starting at negative 2 now, and behavior as x goes to infinity, y goes to infinity. As x goes to negative infinity, y goes to the horizontal asymptote, which in this case is negative 2. Now, the x-intercept, you're going to put in 0 into your equation, right? So, for example, we want x-intercept means y is equal to 0. So we're going to say 0 is equal to e to the x minus 2. So then e to the x equals 2, and x is equal to ln 2, right? So that's this point right here. Actually, my graph is not great. Let me just redo this so it looks more like that. So here 2.7 is about there, and then the graph's like that, right? So this ln2 is that x value where we intercept the x-axis. So this is ln2 comma 0, okay? Okay, and so that's the e to the x with up-down transformation, and I'd like you to know the ln x, right, which is the inverse of the e to the x. So you take these numbers that we did up here, right, for the e to the x graph, and you swap the x's and the y's. And so my numbers would be for the ln x graph 1, 0, e 1, 1 over e negative 1, and these are my x's and y's, right? So 1, 0, e, which is about 2.7 over 1 up, and then 1 over e, which is 0.4, right? So just a little less than a halfway through the first tick, negative 1. And I'm assuming that my scale is 1, 1, 1, okay? So, and then you just connect these, and you know that the ln graph is going to have a vertical asymptote. The vertical asymptote is going to be right here along the y-axis, okay? So here our domain is going to be 0 to infinity, because the argument, the x value of the log function, has to be positive. The range is going to be negative infinity to infinity, and behavior x goes to infinity, y goes to infinity. X can only go until the vertical asymptote here, right? We have like a wall here that the graph cannot cross over. So we'll say x goes to 0, that's the furthest left you can go. And if you do that, y here is going, as x gets closer and closer to 0, y is just going down further and further. So y goes to negative infinity. X-intercept, well, in this case, you just get it right off of the graph. It's just 1, 0. And the asymptote is a vertical asymptote, so line x is equal to 0. And in terms of transformations, you just need to know how to move that graph left-right. So I could give you y is equal to ln x plus 2, right? That's it. That's the only type of transformation you need to know on the ln graph. And all that does is move your graph over 2 to the left, right? So your asymptote now winds up here at negative 2, right? In this case, my h is equal to negative 2. My hk is now negative 2, 0, okay? So I just move the whole graph over. You can literally take these points and, that we had here, and shift them over by 2 to the left, and you would get the graph you need. So our hk here for this equation is negative 2, 0. So basically that's here, negative 2, 0. That'll always be on the asymptote. And then from there, it's these same points that we did for the ln graph, except we're now counting from the new origin. So it's like an over and an up. 1, 0, E1, 1 over E negative 1. So we just come here, 1, 0, E, which is 2.7, 1, 1 over E negative 1, and then there's the graph, right? So that would be this equation, ln x plus 2. Domain would be, now here, this becomes negative 2 to infinity, the range negative infinity to infinity, and behavior as x goes to infinity, y goes to infinity. And for this, it's where you have the vertical asymptote. As x goes to negative 2, y goes to negative infinity. X-intercept, you can see it here on the graph. It's equal to negative 1, 0. And the asymptote is a vertical asymptote at x is equal to negative 2. So that's graphing of e to the x and ln x. You need to know that. You need to remember the conclusion from our E worksheet, which is that the limit as n goes to infinity of 1 plus 1 over n to the n is the number E. You need to remember that E is approximately 2.71. I threw in pi here just to remind you that E is like a number like pi. Pi is about 3.14. E is about 2.71. 1 over E, we did this in our calculator, and it is 0.37 if you cut it out to the second decimal place. So you need to know those. Those are useful just to know. These are approximately, I should say, really approximately. Okay, now the last thing we need to know is the fact that e to the x, I'll write it here, e to the x and ln x are inverse functions, right? So that means that when we make a composite function, when we put f of g of x, remember if you do this and you get x, that's what happens when you have inverse functions. So imagine we call this one f and this one g, right? So because they're inverses, these two things are going to be true. So look at what happens when we put ln into e, right? So we go e to the ln x, and this is going to be equal to x because these two operations undo each other, okay? Same thing happens when we do ln of e to the x, right? This also is going to end up being x. So we can use those two equations to simplify a lot of things, right? So first of all, when you have something like this, ln of e to the 1, again, if these two things undo each other, we're left with a 1. ln of e squared is 2. ln of e to the negative 1 is negative 1. ln of e to the negative 2t is negative 2t, right? So this is just recognizing that when ln and e are happening right one after the other, they undo each other and you're back to what you started with. And so that's how you do those problems. If you have, let's see, let's look at this one, e to the ln x, right? That's x. E to the 2 ln x. Now be careful here because the e and the ln are not right next to each other. They are separated by that 2, right? So you're going to write it like this, e to the ln x squared. Put this back into the log as a power. And now the e and the ln are right next to each other, and the answer is x squared. Here, the e and the ln right next to each other, answer is t minus 1. ln of e to the 0 is 0. E to the 0 we know is 1. That, by the way, goes with the fact that ln of 1 is 0. Let's see. ln of e to the 3.2 will just be 3.2, okay? So I think, we've talked about that in passing, but you need to be able to simplify these type of expressions without a calculator. And that's the end of the second handout. We'll talk about both of these in class and take any questions that you have. And I look forward to seeing you all tomorrow. Bye.